Introduction to Networks Final Packet Tracer Skills Assessment, PTSA. Okay, device names table, R1, S1, PCA, and PCB. Okay, the devices, addressing requirements, the base address, requirements, you will configure the R1 router and S1 switch. You will also connect two PCs using a switch and router. You will subnet the 192.168.10.0 prefix network to provide IPv4 addresses for two subnets. The larger subnet LAN 1 requires 100 hosts, and the smaller subnet LAN 2 requires 50 hosts. Build the network. Build the network according to the logical topology. Cable the network. Connect the hosts. Okay, first place the devices. This is the router, and this is the switch. Okay, router and switch. Drag the device. Also the switch. Okay. Okay, R1 connected to the power distribution device, and S1 connected to power distribution device, and cable the network gigabit from R1 gigabit 000 to PCB. Okay, use the copper straight through cables. Okay, choose one. From gigabit 000 on router to PCB. Okay, here to fast Ethernet 0. Not here, this is RS-232 port. Connect to fast Ethernet 0. Okay, now you can see the connection. From gigabit 001 on router to fast Ethernet 5 on switch. Choose a cable from gigabit 001 on router to fast Ethernet 5 on switch. And finally, from fast Ethernet 6 on switch to PCA. From fast Ethernet 6 on switch to fast Ethernet on PCA. Very good. Develop an IP addressing scheme. You will develop an IP addressing scheme. You will subnet an IPv4 network to create two subnets. Okay, work with the following information. IPv4 network, the base address is 192.168.10.0, prefix 24. Required number of hosts in LAN 1, 100 hosts. Required number of hosts in LAN 2, 50 hosts. On 192.168.10.0 prefix 24. Okay, the first subnet is LAN 1 with 100 hosts. And the second LAN 2 with 50 hosts. Okay, start with the highest number of hosts, 100. Okay, do not start with 50, start with the highest number. Okay, I will place this is the base address, the base network address. I will place the two first octets in decimal 192.168. But the third octet in binary, 10 in binary, okay, with 8 bits. 10 in binary is this. Okay, this is 10 in binary. 8 plus 2, 10. Okay, very nice. Now, 0 in binary, 0 in binary, all zeros, very good. And find a prefix or subnet mask for 100 hosts. Okay, number of hosts. Number of hosts, 126 is a good number for 100 hosts. Okay, so this will be the subnet mask or prefix. Okay, 126 is a good number for 100 hosts. So this is the prefix or subnet mask. And this is the network address for this subnet. The network address for this subnet. 192.168.10.0. 192.168.10.0. And the prefix is 25. Okay, 8 bits plus 8 bits, 16 bits, plus 8 bits, 24 bits, plus 1 bit, 25 bits. 25. Okay, now copy this, only copy, and fill the remaining spaces with ones. Okay, so this is the broadcast address for this subnet for LAN 1. 192.168.10. 127. 192.168.10. 127. And the same prefix 25. Okay, the same prefix 25. And obviously you can see this is 127. Okay, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 127. So the first host for this subnet for LAN 1 is 192.168.10.1 with the same prefix. Okay, one number next to the network. If network is 0, the first IP host is 1. and you can find the last IP host is one before the broadcast. If broadcast is 127, the last IP host is 10.126 with the same prefix 25. Okay, very good. Now you can find the next number in binary of this. Okay, the next number of this in binary is 192, 168, 00, 1010. If you have 7 ones like this, okay, if you have 7 ones like this, the next number in binary is 1 followed by 7 zeros. Okay, the next number of 7 ones is 1 followed by 7 zeros. Very nice. This is the next number in binary. But you can find a prefix for 50 hosts. The prefix for 50 hosts you can find here, hosts. 62 is a good number. So this is the prefix. Okay, and this is the network address for this subnet for LAN 2, 192, 168.10, 128. 192, 168.10, 128. Okay, but the prefix is 26. 8 plus 8, 16 plus 8, 24 plus 2, 26. 26. Okay, and now you can verify also if the previous broadcast is 127, the next network address will be 128, the next number. Okay, so this is very good. Now, allow the broadcast, copy this, and fill the remaining spaces with ones. Very good. This is the broadcast address, 192.168.10. This number is is 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 191. 191. Okay, or 128 plus 63, 192, 168.10. 128 plus 63 is 191 with the same prefix 26. The prefix in this subnet is 26. Okay, so the first IP host is 1 next to the network address. If network address is 128, the first IP host is 129. Okay, with 26. The last IP host is 1 before the broadcast, 192, 168.10, 190. Okay, the broadcast is 191. Last IP host is 190. And that's it. This is the addressing scheme. Okay, using VLSM. Okay, very nice. Assign the first IPv4 address of each subnet to a router interface. LAN 1 is hosted on R1 gigabit 001. Okay, now you can see LAN 1 on gigabit 001. Okay, and LAN 2 on gigabit 000 on router. LAN 2 on gigabit 000 on router. Okay, assign the last IPv4 address of each subnet to the PCs. Okay, on LAN 2, the last IP host for PCB. On LAN 1, the last IP host on PCA. Okay, and assign the second IPv4 address on LAN 1 to switch. Okay, and okay, on LAN 1, the first IP host for the router, the second IP host for the switch, the last IP host for PCA. On LAN 2, the first IP host for router, gigabit 000, and the last IP host for PCB. Now, configure basic device settings. Network devices must be configured over a direct console connection. Connectivity between the hosts should be established. Okay, first, power on the devices. Click here on router. Click here to power on the device. Now it's green. Switch is already power on. Power on the PCs, PCA, PCB. Very nice. Okay, and now use a console cable. Okay, this. Okay, and choose the console cable, light blue cable, and connect from port RS and connect from RS-232 port on PCA and go to console port on router R1. Very nice. Now you can see this connection. And to configure the switch, I will use PCB. Select another console cable from RS-232 port on PCB, and to find the console port on S1, right click, inspect rear. This is the console port. Click here. Now you have the connection. This connection, very good. Now you can configure the devices. Go to PCA, desktop, terminal. The default values 9600 bits per second, and another options. Would you like to enter initial configuration dialog? No. Enter. Okay. Configure basic settings. Disable DNS lookup on R1 and S1. Okay, I will configure R1 first. Okay, disable DNS lookup. First, enable. Configure terminal. Okay, disable DNS lookup. No IP domain lookup. Router hostname R1. Hostname R1. Okay, uppercase. Okay. The switch I will configure later. The banner for R1. Okay, banner, message of the day. For example, unauthorized access is prohibited. Unauthorized access is prohibited. Enter. Allow console logins with the password. Use this password. Okay, for console. Okay, so access to line console 0 because it's the only one port. Password. use this. Be careful, case sensitive. Okay, C uppercase, this NS P uppercase, plus W exclamation mark. Okay, be careful, should be the same. Enter. And login to enable the access. Okay, exit to go to global configuration mode. Now configure interfaces on router gigabit 000 and gigabit 001. Okay, and the description, the IP address and subnet mask. Okay. Okay, first configure okay, gigabit 001. Interface gigabit 001. Description. Okay, you can add a description like this, LAN 1, for example. Okay, LAN 1 is only a text, informational text, but the gigabit 0001 for R1. Okay, remember for on this table on R1 gigabit 001, the first host address in LAN 1 subnet. This is LAN 1, the first host address is this, 192.168.10.1, prefix 25. IP address 192.168.10.1, prefix 25. But 25 in decimal is 255, 255, 255, 128. Okay, and no shutdown to enable the interface. Okay, very nice. And now configure gigabit 000. Gigabit 000 on the another side. Gigabit 000. And obviously the description is LAN 2. But on gigabit 000, first host address on LAN 2 subnet. This is LAN 2. The first host address is 129 with 26 prefix. Okay, 129, 26. 129 and 26 prefix in decimal is 192. Okay, enter and no shutdown to enable the interface. Enter, enter. Very good. Exit. Okay, global configuration mode. Okay, and configure the switch 1. Go to step 1 and configure switch 1. So you need to access PCB, desktop, terminal. Okay. Okay, enter. Enable configure terminal or conf term. Okay, disable DNS lookup. No IP domain lookup. Hostname S1 uppercase. Banner message of the day. Unauthorized access is prohibited. Enter. The console password, line console 0 password. Be careful. Okay, verify. Enter. Don't forget login, exit. Okay, you are on global configuration mode. Then configure the interfaces. Okay, configure S1 VLAN 1 switch virtual interface. The description, IPv4 address, subnet mask, and the switch should be reachable from devices on other networks. So configure the default gateway. Okay, IPv4 address for switch, second host address in LAN 1. Okay, and first access to switch virtual interface VLAN 1. Description, for example, LAN, you are on LAN 1. And IP address. Okay, the second IP host on LAN 1. This is LAN 1. The first is 10.1, so the second is 10.2. Prefix 25. Okay, and 192.168.10.2. 25 in decimal is 255, 255, 255, 128. Okay, 28. Be careful and not shut down to enable the interface. Very nice. Exit. You are on global configuration mode. Okay. The default gateway for switch 1 is the IP address of gigabit 001 on router. Okay. Go to PCA. Now you configured the router on gigabit 001. On the topology, you can see the gigabit 001 IP address is the default gateway of the switch. Gigabit 001. So this is the default gateway for the switch 192.168.10.1. Okay, go to PCB. IP default dash gateway 192.168.10.1. Okay, very good. Ready. Okay, now configure security settings on R1 in S1. Okay, configure enhanced password security. Configure don't tell anyone encrypted privilege exit password. Okay, go to PCA. This is for router configuration. You can see R1. Okay, and enable secret. And use this password, don't tell anyone, with case sensitive. Don't tell anyone. Okay, be careful, verify. Enter. Encrypt all plain text passwords. Service space password dash encryption. Okay. Set the minimum passwords length to 10. Okay. And okay, this will work only on R1. Okay. Security passwords min length 10. Enter. Okay. Now configure SSH for R1 and S1. The domain name netsec.com. IP domain -name netsec.com. Configure local user netadmin with secret password. Use this. Okay, and username netadmin lowercase and secret password. Use that case sensitive $C code 12345. Okay, be careful with username and password, secret password. Okay, verify and very good. Enter. Set login on BTY lines to use local database. Okay, configure the line BTY from 0 to 15. Okay, you have 16 connections here. Login local. Okay, to log in using the local database using this username and password. And now configure BTY lines to accept SSH access only. Transport input SSH. And finally, generate RSA crypto key using 1024 bits modulus. Okay, exit. On global exit from BTY line. On global configuration mode, crypto key generate RSA general dash keys modulus 1024. Enter. Very nice. Okay, and do this also on the switch from part 4 step 1. Okay, go to PCB. Okay, now you are on switch 1, global configuration mode. The encrypted privilege exec password, enable secret, don't tell anyone. Okay, don't tell anyone. Enter. Encrypt all plain text passwords. Service password dash encryption. The minimum password length only for router. Configure SSH like router. IP domain dash name netsec.com username netadmin secret CI dollar CO 12345 CI dollar CO netadmin. Okay, very good. Line BTY 0 to 15. Login local. Transport input SSH. Exit. Crypto key generate RSA general dash keys modulus 1024. Enter. Very good. Okay. Ready. Secure switch ports on S1. Shut down all unused ports on S1. Okay, go to PCB, S1, interface range. Okay, now you can see on switch ports in use 5 and 6. So shut down all another ports from Ethernet 01 to 4, comma, from Ethernet 07 to 24, comma, gigabit 01 and 02. Okay, shut down. Enter. Okay, very good. This range, shut down. Okay, exit. Enter descriptions for all unused switch ports to indicate that they are intentionally shut down. Okay, access again to that range. Okay, up arrow to repeat this command, not a description. Shut down for admin. Shut down for security. Okay. Any description. Okay, exit. Okay, finally configure the hosts and verify connectivity. Configure both hosts with IP addresses. Okay, go to PCA, close this, go to IP configuration, configure IP address subnet mask. Okay, for PCA, last host address in LAN 1. This is LAN 1, last host IP is this 126 prefix 25. Okay, 192.168.10, 126, 25 in decimal 128. The default gateway is 192.168.10.1. Okay, why 10.1? Because for PCA the default gateway is gigabit 000 on R1. And remember, the IP address of gigabit 001 is 192.168.10.1. Okay, go to PCB, close this, IP configuration, IP address, and for PCB, last host address in LAN 2 subnet. Okay, last host address. This is LAN 2. Last IP host is 190 prefix 26. Okay, 192.168.10 and 190 prefix 26 is 192 in decimal. The default gateway is 192.168.10. Okay, and remember the gigabit 000 IP address on router R1 is this 129. Okay, it's the first IP on LAN 2, 192.168.10, 129. Very nice. Now verify connectivity and go to PCA. Or better, go to PCB, close this, go to command prompt and ping PCA IP address. Ping PCA IP address. Okay, go to PCB, ping to PCA 192.168, 10 that the IP address of PCA is the last on LAN 1, so it's 126. 126, okay. From PCB, ping PCA 126. Okay, success, very good. Okay, ping the switch is the second IP address on LAN 1. If the first IP is 1, the second is 2. The second is 2. Okay, now from PCB, ping the switch. Okay, very good. You can repeat. Now, very nice. Now, ping gigabit 001 on router 1 is the first on LAN 1. The first IP is 1. Very good. On LAN 2, ping gigabit 000 on R1. On LAN 2, the gigabit 000 IP address is 129, the first IP. Go to PCB. 129. Okay, very nice. And all is working very good. Okay, but why the completion is only 58%? Check results. Click here. Okay, the banner on R1, the descriptions. Okay, on R1 the banner is incorrect. or on gigabit 000 the description is incorrect. On gigabit 001 the description is incorrect. So that the creator of this activity, for this packet tracer activity, the creator used a custom or a specific banner and a specific descriptions. And the packet tracer activity is expected to use the exactly same text, the exactly same banner, the exactly same descriptions. Obviously, you don't know what was the description used for the creator of this packet tracer, but on real exam, you can use any banner, any description. Also for S1, the banner, the descriptions on interfaces, the description on switch virtual interface, and any other items are very good. So don't worry if you have this score 41 of 70. That means only the 58%. Don't worry. Okay. I think we got 100%, my friends. Thank you very much.